In this section, we're going to talk about, in section 6, we're going to talk about properties of logarithms. And because logarithms are so closely related to exponential functions, that is that any logarithmic equation can be turned into an exponential equation, and any exponential equation can be turned into a logarithmic equation. Because that's true, a lot of the properties of logarithms are similar to the properties of exponents that we've learned in a previous chapter. So I'm going to go through the properties, and they look sort of if you're wondering where they come from, all of them can be deduced based on the properties of exponents. Now, I'm not going to show that, but that's where these properties come from. They don't just fall kind of magically from the sky. So the first property of logarithm is the product rule. Okay, and this says that if you have a logarithm with a product inside of it, then you can break that logarithm up into the sum of two logarithms. So if I had the log base b of 7 times x, I could break that into the log base b of 7 plus the log base b of x. Same thing with the quotient rule, except that instead of addition, it's subtraction. So if I have two things being divided, I can break that into subtraction of two logarithms. And the last one here, this is really useful. If I have a power inside of a logarithm, I can move the exponent out in front of the logarithm. So we can use these rules going in both directions too. So we can take one logarithm and break it apart, or we could take two logarithms in this format on the right, or a number times the logarithm in this format, and we could send it back the other way. So these work in both directions. So if you have a problem that says something like condense the expression, what we're going to be doing is we're going to basically be going from the right-hand side back to the left-hand side, okay? So if I have log base 3 of x plus 2 log base 3 of y, the bases are the same, so we can apply the properties. The first thing that we're going to start with is getting any exponent, or any number that's out in front of the log, into the exponent. So this 2 can go up into the exponent of y, okay, following this rule here, taking the c. Notice how the c goes back into the exponent. Okay, and so what we're going to do then is write this as log base 3 of x plus log base 3 of y to the second power. Then we're going to combine using sums and differences, and in this case it's just a sum, but the sum property here says it can be condensed into one logarithm with multiplication inside of the parentheses. So this will become log base 3 of x times y squared. All inside of one logarithm. And that's condensed. Condensed means put it into one logarithmic expression. Now we're going to shift to solving equations, and the thing with solving equations is that we're going to use the properties in the context of solving the equations. Now, this expression right here we can solve in two ways. One is just to look at this and notice that you have the log base 4 of both sides, and if you have the log base 4 of a thing on the left and the log base 4 of another thing, those two things have to be equal to each other inside of the parentheses. Those two things in the parentheses have to be equal to each other. Another way to think about this is, if you want to undo a logarithm, a log base 4, in this example, you can take and what's called exponentiating both sides with the base 4. Since logarithms and exponentials are inverses of each other, we can go 4 to the log base 4, those are inverses, and so I get x minus 1. 4 to the log base 4, and I get 2x plus 5. Now, that's probably not the way that I'm going to do it usually. I think it's just quicker to just be like, hey, look, log base 4 on each side, those things got to be equal. But then we get down to this equation, which is just a matter of solving for x. All right, so, or just a linear equation. So I'm going to subtract x to both sides and get negative 1 equals x plus 4. Move the 4 over, I get negative 5 equals x. Okay, so let's do some more where we have to actually use the properties, and that one we didn't have to, but let's look at this one now. So in this one, we have two logarithms on the left, one on the right. They're all base 3. The ones on the left, I'm going to take and combine together using this property, which is the sum of two logs could be written as the multiplication, the log of the multiplication of one inside of one logarithm. So this will become log base 3 of 6x equals log base 3 of 12. Log base 3 of a thing equals log base 3 of a different thing. The thing and the different thing have to be equal. So in other words, we can write this, that 6x has to be equal to 12. Then we can take and divide both sides by 6, and I get that x is equal to 2. All right, next one. Solve the following equation. Again, we've got a situation of a bunch of logarithms. Let's use the properties to help us out here. I've got 2 in front of the logarithm. I'm going to move that into the exponent using that last property. I've got a sum over here, so I'm going to combine this together using one logarithm, or in one logarithm, where it's going to be 27 times 3. So this will end up being log base 7 of x squared. This is equal to log base 7 of 3 times 27, because again, we're multiplying. That's going to be 81, I think. Yeah, 81. Okay. And then we'll take 7 to the left. Oh, sorry. We'll look at this and say log base 7 on both sides, so the x squared and the 81 have to be equal to each other because they have the same log and base. So we have x squared equals 81. When I square root both sides, plus or minus, I get x equals plus or minus the square root of 81, which is 9. And then we have to check our answer here because log base 7 of positive 9 is possible. Log base 7 of negative 9 is not possible. All right, so we didn't touch on this a lot, but when we were talking about graphing, or when we were looking at the graphs of logarithms, you'll notice that many of them had a vertical asymptote at some point. And if there was no transformation, it was at x equals 0 because you can't take the log of a negative number. So this, our final answer here will just be x equals 9, the positive 9, not negative 9, right? Next, solve the following equation. Now these two you should give a try. You should try them and then see how it goes, and then play the video and check your answer. All right. Log base 6 of x equals log base 6 of x minus 9, which equals 2. I'm going to combine the logarithms on the left-hand side, so I'll get this. Log base 6 of x times x minus 9. That's all inside of one logarithm. It's all equal to 2. And now I'm stuck, right? I've got this log on the left and this and just a number on the other side. So what I'm going to do is change this to an exponential and go from there. So, or you can think of it as 6 raised to the left and 6 to the right. That works as well. 6 to the log base 6 are inverses of each other, but you'll end up at the same spot. You get x times x minus 9 is equal to 6 to the second power. And now we've got an equation that we can solve that doesn't have any logarithms in it. So x times x is x squared minus 9x equals 36. This is a quadratic equation, so we're going to move everything to one side. So I get x squared minus 9x minus 36 equals 0. You can solve this with the magic x if you want to. It turns out to not be very tough to do, just kind of guess and check, but the magic x will always work. So I get x here, and your numbers are multiplied to give me negative 36 and combine to give me 9. It's going to be, you can kind of make a list. So 36 and 1, that's not going to work. You can go 9 and 4, that's not going to work. You can go 12 and 3, and there's our combination right there, right? So I'm going to have x minus 12, x plus 3, because I need a negative 9 there. And so my two answers will be x equals 12 and negative 3. And again, checking our answers, negative 3, if we plug that in, we'll get log of a negative, which is impossible. So x equals 12 is my only answer. All right, last one. This is a question that's similar to this, but it's phrased differently. It says, state whether the following identity is true or false. In other words, does this actually equal this? And then, can you prove it or not? Let's look at the right-hand side. There's not much we can do to the left. That doesn't really follow a property, but on the right-hand side, we have log base 4 of z plus log base 4 of 2. That can be combined to be log base 4 of z times 2, or maybe we could just write 2z. Okay, is that equal to log base 4 of z plus 2? No, it's not, right? These are two different things, so we would say that this identity is false. And if we were asked to prove it, this is the proof, that those two things are not equal to each other. This we know by the properties. This we can't change, and so it's got to be false. One thing I should say on this one is it's very, very easy to look at this and be like, oh yeah, that makes sense. Log base 4 of z plus 2 is equal to log base 4 of z plus 2, or log base 4 of 2. And that's not how the property works, though. And that's why there will be problems like this in the book to see if you actually understand the properties, or if you're just kind of looking at it being like, oh, a plus and a plus, fantastic, right? So we can make a lot of different types of problems with where you have to use the properties of logarithms. Here are a few, but I think that should get you, that should pretty much cover section 6.6.